Hi guys, so for today we are starting a brand new unit actually. Last Friday we wrapped up with trapezoids, and that's really the last thing I wanted to do with quadrilaterals, so we're actually going to move on to a completely new unit. The unit after quadrilaterals was supposed to be circles, but I think this unit is more applicable to like real life. It's more applicable to ACT type questions. I'm still hoping to go back to circles at the very, very end, but I just want to make sure that I got to this unit before circles because I think it's a little bit more important. So, but I'm going to try to make sure that we have everything we need from circles in order to do this unit. And that's just like a little bit of vocabulary. So this unit it starts off with area. Area should be something that you did in middle school and possibly even in Algebra 1, just with like some simple substituting for equations, that sort of thing. But I know we don't remember all those formulas. Some of the formulas I don't even remember. Like, there's just some that you don't use quite as often, so they might not be just something you remember. So the first thing we're going to do is like a little bit of review of just flat out area, and then a little bit of perimeter possibly. And then the second half of this unit is volume. So the first part is area. So area is talking about plane figures, and that means they're two-dimensional figures. So they're something that you can see like on a piece of paper. Whereas when you start talking about volume is when you get into these types of 3D figures, okay? So we don't have to worry about volume just yet. We're only going to worry about area and perimeter this week, okay? So area and perimeter, which, by the way, this is like a reference sheet. I'm going to upload this hopefully on Monday. I think on Monday. And this is just a nice thing to have. I think this could be something that you could use right before an ACT. I know I have a lot of sophomores that are going to be juniors next year, and this is a really good reference sheet to hang on to before you take that ACT type test and just kind of familiarize yourself with all these formulas. This top row, these are the 4 that I think you should have memorized by the end of your sophomore year, by the end of your geometry course, okay? So this first one, which all of these are in the notes that I'm about to do, which I might even just go to those real fast. There they are. So this should be at the top of the notes page that I have for Monday, and these are all the ones that we're going to use today. The ones that I think you should memorize are the triangle, and I'm just going to put rectangle because if you know the rectangle formula, then you know the square, okay, and we'll talk about that. And then circle, okay, so circle is one that comes up a lot, so I think these 3 for sure you should know how to do without even using the formula sheet. So the first one, a triangle, let's just talk about what this formula means. When it says A equals, that uppercase A is area. So the area formula for a triangle, or any triangle, is going to be 1/2 times base, so the base of the triangle, and times height. The base is always what the triangle is like sitting on, okay? So it's going to be the longest side as well, and or not the longest side. It's whatever the triangle is sitting on, and whatever this the height is coming in contact with. Sorry, I just like really butchered that. We're going to do a lot of examples with triangles though, especially because this is kind of a weird thing to think about, but typically it's going to be wherever the base and the height intersect, okay, to form that right angle right here. Next, talk about rectangles. So rectangles and squares. This one includes squares. I mean, knowing square, like this little shortcut is nice, but as long as you know the formulas for a rectangle, you should know how to calculate a square. The They're both just two four-sided shapes. The only difference is a square. All the four sides are the same length. So instead of using length times width for area, they just say S times S, which is the same as S squared. Okay, so however you want to think about it, I've always just thought about the area of a rectangle, length times width, and that seemed to get me pretty far in life. But then they also give you the perimeter formula. So perimeter is the length outside of any two-dimensional figure. So if we had find the perimeter of a triangle, we would just add up all these sides. That's why they don't give you the actual formula. For a rectangle, they kind of reduce. Instead of doing like this side plus this side plus this side plus this side, they do 2 times L, so this side plus 2 times W, so W plus W. Okay, so they're just shortening that perimeter equation to 2L plus 2W. And same thing over here, since all four sides are S, instead of saying S plus X plus S plus S, you would just say S times 4. Okay, so again, however you want to think about it, if you want to remember another formula and remember square is different from a rectangle, that's fine, but I think just sticking with the rectangular formula would be fine. Let's skip these for now. We'll go to a circle. So circle has a little bit more vocabulary that we might not have heard yet. I think this picture does a really good job of showing you what they mean. So the C, let's make note of this real fast. C equals the circumference. And the circumference is, think about it as the circle's perimeter. Okay, so the circumference would be like this outer ring of the circle. That's just a more specific term for circles because they're not as they don't have those nice sleek shots. They don't have the sides like a rectangle or a triangle would. So they're called the circumference. And so the circumference would be 2 pi r. Your r is coming from the radius. Okay, so r equals radius. And I'm hoping we know what radius is, but in case you've forgotten, radius is half of the diameter. So if I took the center point in this circle and I made a line from this center point out to the outer ring of the circle, that would be the radius, okay? And then the diameter is exactly, if I were to cut this circle in half, it'd be the length from one side to the other, okay? So that's what the D is. D is diameter. So really what the diameter is, it's 2 of your radius. So diameter is 2r. So that's why the circumference can either be calculated as 2 pi r or just pi times the diameter, because your diameter is really 2 times r. So either one you want to think about. It just depends on whether or not you have the diameter or you have the radius, or which one you want to calculate. However, for area, so the area within the circle, that has to be calculated by pi times r squared. Okay, so area is pi times r squared. And you want to use, whenever you're putting this into a calculator, you actually want to use that pi button. Okay, so I know on the like if you're using your phone calculator, I know that has a pi button, I believe, if you turn it sideways. I forgot to check that when I started this, but I'm pretty sure that if you turn it sideways, there's a pi button. If you use the calculator apps that I've told you about, Desmos or that Calculate 84, I know for sure they have the pi button, and that would be easy to use as well. Okay, so those are the 3 that I think you should really know, or try to memorize within this time. I'm never going to know exactly if you've memorized it because all of your tests that you take are open note, but I think in the long run, if you really want to prepare for the ACT or any type of standardized test, really memorizing these would help you out, because they're not going to give you these formulas on those tests, which really stinks. But the last two on here are this, hopefully you recognize, as a parallelogram. Okay, so parallelograms, you're going to take the base times the height and just multiply those together to get the area. And then for this is that last shape that we talked about briefly, is a trapezoid. Okay, so trapezoid, you're going to take, you're first going to take the bases. So here's base 1, here's base 2. You're going to add them together, multiply them by the height, and then multiply them by a half. Or, okay, whenever you multiply something by a half, you're really dividing it by 2. Okay, so the same thing up here. Base times height divided by 2. That's another way people like to talk about the area of a triangle. So let's just start some problems. I'm going to do all of these problems, whether you follow along or not. And then your quiz today is going to be a little longer, but it's going to be more worth more points, because I just want to give you guys some more points. But it's not going to be based on this per se, but it is going to be based on area. It's just not going to come directly from these notes like it typically would. But as long as you know how to use these formulas and plug things in, you're going to be fine. So for all these, I'm going to try to say what type of shape they are before I go into the actual formula. So for number 1, the first thing I notice is that these two are the same length, and that this shape has all right angles. So I'm already going to say that this is a square. And a square's formula for the area would be area equals, you can do length times width, or you can do the s squared. Okay. So area equals 8.5 times 8.5. Okay. See how those would be the same thing as like 8.5 squared? That's what they're getting at with, or that's what I'm getting at with the rectangle formula and the square formula are the same. So then the area of this plane figure would be 72.5.25, my bad. And then you always want to put your feet. And then since you are talking about area, you're always going to use feet squared, or whatever your unit is, and you're going to use that squared, because the squared means you're multiplying by something, okay? And that's just typically what the area unit is. It's something squared. For number 2, I have a triangle, it looks like, a 3-sided shape. And so a triangle, its area formula is 1/2 times base times height, or base times height divided by 2. So my base is going to be 15, and my height is 21.3 meters. So all I'm going to do is I'm going to say area equals 1/2 times 15 times 21.3. Plug that into my calculator. If you want in your calculator, you just have to put parentheses around all these numbers, and it'll do it for you. So area equals 159.75 meters squared. In 3, I can already tell this is a parallelogram because I have 12.9 inches and 12.9 inches. Those are two congruent pairs of bases, as they like to say. So with a parallelogram, let me write this out. The area formula is just base times height. And so I'm going to take 7.1 times 12.9 to get 91.59. Inches squared. Number 4, I have a circle. So with a circle, my area formula is pi r squared. And reminder that r is the radius. So when I think about my radius, the radius would just be half of the diameter. So I'm given that the diameter is 26 yards, okay? So I need to take half of that. My diameter is 26. That means my radius has to equal 13. Okay, so now I have everything, and I can just plug in r to this formula to get area is pi times 13 squared. Okay, reminder, use the pi button, not just 3.14. I mean, you can use 3.14, but you're just not going to get as exact as I would. So area equals 530.93, and then we're in yards squared. Okay, just looking at 5 and 3. 5 and 3 look a lot similar, and they kind of are, but the key difference, I would say, is these bases. These bases are not the same, so that tells me that this has to be a trapezoid, okay? And a trapezoid has a little bit of a funky area formula. It's going to be 1/2 times height times the bases added together. So we have base 1 and base 2. Okay, so I'm going to call this one my base 1, and this is my base 2. Now I got to figure out what's my area. Now, the biggest way to figure out what your area is wherever that right angle is formed, okay? Some people want to put 21 or 16.5 just because, oh, like it's the height right there. But that's not really the true height of this trapezoid. So the true height is formed by making this perpendicular line with the bases. So my height has to be 16. Okay, so now we have everything to find area. So I take area. Oh, whoops. There you go. Area equals 1/2 times height. Oh, I'm getting crazy. Height is 16. And then I'm going to multiply that also by taking 19 plus 27. Okay. And so when I do all of that in my calculator, I'm going to get area equals 368 centimeters squared. Six is not a square, but it is in fact a rectangle. I know it's a rectangle because it has 4 sides and it has all right angles. Okay, so that's the only way I can use the area formula, which is length times width. So you could call this your length and this your width. It's not a huge deal either way. The only time that it might become a bigger deal is like in word problems if you have to actually draw and they want it positioned a certain way, but typically it doesn't matter which one you call your length and your width. So for area, I'm going to take 10.5 times 3.7. Make sure that looks like a times. And I get 38.85. And we're using kilometers squared. All right, 7 looks really weird because you're like, oh my gosh, there's like 2 triangles, 3 triangles. I don't know what's happening. So the area that we're finding is of this triangle that I'm coloring in, okay? I know it looks like it's an even bigger triangle because of this dotted line here, but this dotted line is creating what's called the altitude, and it's making, it's giving me the actual height of this triangle, okay? So typically, I'm not sure if they would give you this on an ACT, but for these problems that we're doing this year and right now with NTI, I'm always going to give you this drawn in, and you're never going to have to actually find that height of the triangle. I'm just going to give it to you, okay? So the height, you're always going to look for, okay, where's that right angle being formed? I'm going to look straight up from that right angle, and that's going to tell me the height. So this is my height. And then again, wherever that right angle is being formed with, that's your base. So I'm going to follow height, and then here's my base, okay? So my base has to be this 29.5. So again, triangle. And the area is 1/2 times base times height. And so I'm going to take half of 14 times 29.5 to get 206.5 inches squared. With 8, I noticed that it looks like a parallelogram, and I can say that it's a parallelogram because of these 2 sides right here being congruent, okay? So since those 2 sides are congruent, I can say it's a parallelogram and not a trapezoid. So for a parallelogram, my area formula is just base times height, okay? So my height, again, is coming from this altitude being formed with this tiny little right triangle. So my height is not going to be 18.5. That's like a slanted height, okay? So that's not the true height of this parallelogram. It's actually going to be this 16.1. So my base is 11.8. So my area equals 11.8 times 16.1, which turns out to be 189.98 meters squared. Okay, so number 9, I have like half of a circle, okay? So I don't have this full circle. I only have half of it. We're going to act like I have the full circle and then determine half of that circle at the very end. So what I do have is this 17 feet. Now this 17 feet is only pointing from the center of the circle to the edge. So that makes me know that the 17 feet is in fact the radius and not the diameter. That's a U, sorry. So with a circle, my area formula is pi times r squared. But since I only have half of a circle, I'm actually going to take whatever this area is and divide by 2. Okay, so you can make note of half of a circle is area equals 1/2 times pi times r squared. Okay, because we're taking half of that area because I only have half of a circle. So I'm going to have pi oh wait, I forgot the half. 1/2 times pi times r squared, which is 17 squared. Okay, I'm just going to multiply all those together, and I get 453.96 feet squared. Last one. This one looks kind of funky. I know right away it's not a square, it's not a rectangle. I'm kind of thinking either a parallelogram or a trapezoid. Okay, that's what's going through my mind. Well, parallelograms, they have to have congruent opposite sides, and I don't see that. So this has to be a trapezoid. So already, I'm going to say trapezoid. So for a trapezoid, the area formula is 1/2 times height times base, the first base plus the second base. So I need to have two bases. My bases are always going to be the two sides that are parallel. Well, already right away, I can tell that this side and this side are not parallel. If I continued this line, it's eventually going to meet up with this. So that means this 7 millimeters and 13 millimeters have to be my pair of parallel lines. So this could be my base 1 and this could be my base 2. Now I need to figure out what's my height. My height has to be a straight edge and it has to form a right angle. The only side that does that, that's not either of my bases, is this 5 millimeter. Okay, so there's my height. So now I have everything. I'm just going to plug it into that formula. So area equals 1/2 times 5 times, and then you're going to have 7 plus 13. Okay? And, of course, you're going to add 7 plus 13 first, then multiply to get 50 millimeters squared. Okay, and that is everything. Hopefully you were able to do some of these on your own. If you did some and you were getting something completely different than what I got in your calculator, make sure you reach out to me and just send me a picture, or like say, hey, Miss Jackson, I'm not getting the same answers as you, and we can kind of troubleshoot how you are using the formulas, and I can try to help you before we get to like a bigger quiz or something, okay? So let me know, but I'm hoping this was a lot of just review and we are slowly remembering area a little bit more from like middle school. But that's all I have. So make sure you take that quiz today. It's worth 10 points instead of 5, and good luck.